one question is given, and the question is, this is 1K connected in series with input Vin. Here I have circuit which contain diode D1, and at the negative terminal of the diode I have 4 volt. This circuit is closed. Parallel to this branch I am having another diode branch in which I had diode, and at the positive terminal of the diode I had 2 volt. Okay, this is the circuit, and apart from this I have another parallel branch connected to this circuit, and the value of this branch is 1K. Here I am taking V output, and the V in given as sine wave from 5 to -5. So this is the maximum value. This is about V in. Maximum value is 5 and the lower value is -5. Okay. So V in is given. I have to draw the circuit or draw the waveform for V naught. So this is the clipping circuit. This diode are going to use for clipping the V in waveform. Okay. So let's start the problem now. So we'll do this problem, but in actual problem this 1K is not there, so I'm sorry, I had to remove this. This 1K is not available with us. The question is this much only, right? The question is this much. Let me draw it again. Here I'm taking V naught, right? Now I have to draw the output. Okay, I'll draw the output. Before that, let me take the input waveform. This is input waveform given plus 5 to -5. This is V in. Here only I'll draw the output waveform. Okay. So friends, observe this. This D1 is connected with this 4 volt battery in series, and this is the D2. D2 is connected in series with 2 volt battery. See, if you want to be this diode forward bias, what you need is the voltage here should be greater than 4 volt. Then only the diode D1 will conduct. What about diode D2? For the diode D2 in conduction, the voltage here should be less than 2. Okay. If this potential is higher than 2, the diode D2 will be in reverse bias. If this voltage is less than 4 volt, this diode will be in reverse bias. Okay. So one by one we'll observe the conditions. See, if this V in, suppose initially, if you are studying this subject, forget about these 2 branches. They are not in the circuit. If they are not in the circuit, it means they are opened from the circuit. You are having V in over here. Okay. Now at this stage of V in, you are applying these 2 branches in the circuit, and we are observing what is going there, right? So we have taken V in, and the condition is V in less than 2. Why 2? Because the minimum value of the voltage is 2 given, so I can check the D2. What is the status of D2? I can check. If V in less than 2, it will conduct. Diode D2 will conduct. If diode D2 will conduct, means it will be in short circuit. It will be in short circuit means at the output you are getting directly 2 volt. So in this condition you will get output 2 volt directly, right? But see, what about now? We'll check this condition. The diode D1 will conduct only when V in should be greater than 4. V in should be greater than 4. Then only diode D1 will conduct, because it will turn into the forward bias once the V in reaches 4 volt. In the 4 volt condition, the diode D1 will be short circuited, and at the output stage you will get 4 volt. So V naught will be 4 volt. Now the question is, in between 2 and 4 what will happen when V in is between 2 to 4? Now you can check these 2 conditions. Only one diode will operate at one time, right? When V in less than 2, V in less than 2, will D1 conduct? No, D1 will only conduct when the V in is greater than 4. So when D2 will conduct, D1 will be off. Now let's check what is the condition of D2 when D1 is on. See, this is the condition for D1 on. This condition. This condition is for D2 on. Okay, fine. Let's check here what is the status of D2. When V in is greater than 4. This is the greater than 4. This voltage is 4. D2 is in reverse bias. So at a time only one diode is working. Now let's come to this region in between 2 to 4 volt. 2 to 4 volt. Let's take the value 3 suppose. Let's take the value 3 suppose. What will be the status of D1? Tell me. This is 3, this is 4. Obviously this will be in reverse bias. Now let's come to this. This is 3 volt. If this is 3 volt, this D2 will be in reverse bias. So both diodes will be in reverse bias if the V in region is between 2 to 4. So when these 2 will be in reverse bias, means we can remove these 2 from the circuit, and at the output stage directly you will get the V in. When these 2 branches you will remove, the circuit will be open, there will be no drop across this. Directly this V in you will get at the output stage. So in this case output will be Vn. Let's draw the waveform now. Okay. When V in less than 2. See, here suppose V in is 2. So when V in less than 2, this is the less than 2 condition. The output is 2. I'll draw like this. This is 2. Output is continuous, right? So this red line is the output V0. Okay. Now let's come to the when V in greater than 4. Here suppose 4 is there. Here is 4. When V is greater than 4, after this waveform is given for V. This waveform is given V in greater than 4. In V in greater than 4, throughout the condition is V0 should be 4. So V0 should be like this. Is it okay? What about in between? In between 2 to 4, 2 to 4, 2 to 4, the output follows input. In this case, it will be same as like this. Again here, the value of this is dropping. So means this condition is fulfilling. So output is 2 volt. Like this. So this is your output for this circuit. I hope this is clear to you. This is very simple clipping circuit. Now we'll see some problems based on diode applications and we'll switch to the clamper, right? This is the gate problem 2014, 2 marks. Okay. And the problem is, here is the circuit given. Resistance of 1 kilo ohm connected over here. Here I'm taking output V0. Through this output I have 1K. This is 1K, okay. This is 1K. Let's take it R2 given over here. Here they are connected one diode, and at the negative terminal 2 volt battery, and this is grounded. This is your question. Here you are applying V in. Here you are applying V in. Okay. Now the question is, the diode in the circuit shown has V on 0.7 volt. Let me change the pen. The diode the V on is 0.7, means practical condition we are considering. In the practical diode will be having 0.7 voltage drop. This is the barrier potential, right? If Vi is 5 sin omega t, here Vi in is given 5 sin omega t. Okay, fine, in volts. The minimum and maximum value of V0, they're asking V0 max and V0 minimum. The maximum and minimum value of V0 in volts are respectively, what is these two values? Here is the question from the gate, and the question is 1K is connected with the V in connected in series with R2, that is again 1K connected diode, that is the drop the diode has dropped the 0.7 volt, and at the negative terminal of the diode I'm having 2 volt battery. I have to find V0 max value and min value, right? So how we'll proceed this circuit? So for this particular circuit, Vin is given 5 sin omega t, right? So friends, see, can I find out the current in this circuit? I. Let's take the current. The current is I, and diode is working initially, right? If diode is short circuited in the positive half cycle, obviously it will be in forward bias if the value across this point is greater than 2 volt, right? So let's take the condition 1K, and when diode will work, the drop will be 0.7, perfectly fine. Here the 2 volt like this, and this is V in, and the current is I. Okay, when you will find out the current I, it will be V in. I. You have to find out the I. I is V in minus 0.7 minus 2 divide by 1K, 2K. So current is like V in minus 2.7 divided by 2K. So it's like V in minus 2.7 divided by 2 milliampere. Is it okay to you? Now you have found the current, and here is your voltage drop. So what will be V0? So V0 will be voltage drop across 1K plus 0.7 plus 2. So V0 will be, the voltage drop across it is in this direction because current is coming from V in to ground. So let's take some drop VD, and the value of VD will be current into resistance. 1K into this will be V in minus 2.7 divided by 2 itself. Milli and K will cancel out, plus 0.7 plus 2. This is V0, right? And V in minus 2.7 plus 2.7 divided by 2. The condition is like this, right? So this is nothing but your V0, equation 1. Let's take it equation 1. Now the question they're asking, find out the V0 max and V0 min. Okay, so let me erase some part of the question, and then I'll show you what is the V0 max and V0 minimum, right? So the maximum value of the input means V in is given plus 5. Is it okay? Because you can see in the waveform, the maximum value is plus 5 and minimum value is minus 5. This is here 5 volt and minimum is minus 5. So instead of V in, for the max value, can I consider the maximum value of V in, that is 5. Okay, the max value of V0 when the V in will be high. It's quite obvious, right? So V in is 5 minus 2.7 divided by 2 plus 2.7. So it's kind of 2.3 divided by 2 if I am right, and it will be yes, correct, plus 2.7. Is it okay? So when you will solve it, it will be 3.85 volt. This will be your V0 max. Am I right or not? Please think about this. The V0 max will be max by this equation at which value? When V in will be high or max. When V in will be max, at that value only you will get the maximum value of the V0, right? Because V0 is going to proportional directly to the V in. And what is the maximum value of V in? The maximum value of V in, you can see over here, is 5 volt. I put the value of 5 volt in the equation 1, and at the final stage I'm getting 3.85. So this will be the max value of V0 max. Now come to the minimum value of V0. Let me erase it. So where we calculate the minimum value? At the minimum value of input or not? Tell me. If you want to calculate the minimum value of the V0, you will consider the minimum value of the V in. Yes. What is the minimum value of V in? If we'll talk about the V in value, that is the -5. But think about this. If the V in become -5, here it will be -5, suppose. So what will be the stage of your diode? So your diode will not work. It will be in reverse bias. In the negative half cycle, it will be completely reverse bias. Your diode will be in forward bias only when V in is greater than 2 volt. When V in is greater than 2 volt, and it will be reverse bias otherwise. This is your diode status. Okay. So here the condition is given -5 volt. Obviously the diode will be off. If the diode will be off, this branch is useless for us, and the remaining branch will be, or remaining element in the circuit will be 1K, and this is clearly V0. So in this case, V0 follows V in. So V0 equal to V in, and V in is -5 volt, right? So is it the minimum value of the V0? Yes, this is minimum value. You can't get lower value than this. -6, -7 you can't get. Why? Because your input is limited to -5 volt only. That's why you are getting -5 volt. The answer of this question, 2 marks get question 2014, is the value of V minimum is -5, and the V max is 3.85. For this question, we had options also. In the option A, they have given -5 and 2.7. Option B, 2.7 and 5. Option C, they have given -5 and 3.85. So this is our answer. Okay. This is the max value and this is the minimum value. This is all about this circuit. Let's take another problem. This is the question, again the gate question, and the question is resistance R connected with, over here is this is the input stage given. Okay. Again I'm having diode circuitry like this. The given, this is D1, and D1 is connected with -1 volt. They have given -1 volt. So you can revert this battery also if you want, or let's take the numeric value of -1 only, right? In the parallel branch, they have given D2 over here, and with D2 the 2 volt is connected. The situation is like this, and here we are taking V0 of the circuit. Okay, and the question is now, the question is 2 silicon diodes. These 2 are the silicon diodes, and the question reads as, with a forward voltage drop of 0.7, yes, 0.7 drop is there if they will conduct. We have to assume this, it's given in the question, are used in the circuit shown in the figure. Okay. The range of input voltage Vi for which the output voltage V0 equal to Vi. So what they are saying, find out the range of V in, input range. For that, V0 is equal to V in. Means at what range the input will be equal to the output, and the options are given -0.3 Vi to 1.3 volt. Option B given -0.3 Vi less than 2 volt. Option C, please do it carefully, okay? When you will calculate this and you will get some wrong answer, and wrong option will be given over here, definitely. This is all about the gate. They are checking your aptitude, right? Your knowledge, your deep knowledge. If you will be in hurry and you will do it, definitely you will get one of these options as your answer. So please read it carefully and do it carefully. Okay. And when the questions are easy like this, you should be having more careful. Okay. So the question is, we have to find out the input range for which the output is equal to input. Let's start it. So now I will remove these 2 diodes and will apply this 0.7 volt. Okay. So the direction of the diode is given like this. So the positive terminal of the battery should be this side, and for this, these are opposite to each other. Okay. So let me clear this first, so it will be easy to understand for you. Okay. This is 0.7 voltage drop, and here the drop is to this side, 0.7 volt. Okay. Now if the diode D2, we'll check one by one. Okay. This is 0.7 given over here. This is minus volt. So here if we'll talk about this circuitry, this circuit is providing. Let me change the pen color. For this circuit I'm talking about. Here, if the point A, here the point is B. At point A, the voltage due to this branch will be minus 1.7. This minus 1 and this minus 0.7 is minus 1.7. What about the B? We'll talk about the B. At B, the output voltage is 2 plus 2.7, 2.7. What it means? It means, see, at the B stage, diode was like this. At A stage, diode was like this. Now your first condition, suppose you are starting your problem at this stage. If you want to be short with this diode D2, your task is, suppose you are assuming the diode D2 is in forward bias. When the diode D2 will be in forward bias, and the question is why I am assuming this diode is in forward bias. Why? Because when that diode will be forward bias, the V0 will be no more Vin. The V0 will be 2.7 definitely. And our condition is, we have to check the condition where V0 should be equal to the Vin. Okay. So, we'll remove this by doing the problem in this way. Assume the diode D2 is in forward bias, and when the diode D2 will be in forward bias, when the voltage across B will be greater than 2.7 or not? Tell me. So, the VB should be greater than 2.7. At VB means Vin. Vin should be greater than 2.7. Then only diode D2 will work, or diode D2 will open. And when Vin is greater than 2.7, output will be 2.7. Is it okay? Okay, this stage is fine. Now come to this. Here the diode is connected like this, right? Now at this diode, you need value here. See, I can say this is 1.7. I'm including the drop also. Okay. Now, if you want to conduct this diode, you should be lower than 1.7, minus 1.7 to this terminal C. See, I'm drawing this D1 over here. This terminal voltage is given 1.7 volts. Now your task is, this diode should be in forward bias. If this diode should be in forward bias, so that this terminal voltage should be lower than minus 1.7. Is it okay? If this is VA, this VA should be lower than 1.7. Is it okay? So if VA or this volt, and here the voltage is Vin, obviously Vin less than minus 1.7, in this stage output will be minus 1.7, because this diode will be working and this entire diode voltage will come to the output. Now see the condition. This is your Vin. When Vin greater than V0 is this. So when Vin less than 2.7, situation will be different from this. Okay. Here the Vin less than minus 1.7. So in less than condition, the diode is working and the output is minus 1.7. So what about Vin greater than minus 1.7? When Vin greater than minus 1.7, the diode D1 will not work. Let's check any condition in between. Let's check 1 volt. Vin is 1 volt. 1 volt is coming in between them. What is the output stage? Let's take it 1 volt. This is 1 volt. This is minus 1.7 volt. Will D1 will work? No, D1 will be in reverse bias. Fine. What about D2? What about D2? See, the condition of D2 is given like this. Here is 1 volt. 2 volt is already given on the opposite side or negative terminal. It will reverse bias. When both are reverse bias means they are useless in the circuit. At this time, the V naught is V in, or I can say the output follows input. So where is the option given? Minus 1.7 to 2.7. Minus 1.2 to 2.7. D is your answer. This was the question of 1 mark. Okay. Okay, I'll take another problem. This question is again very interesting. Here diode D1. Here diode D2. Let's take it D1. Let's take it D2. They are connected in this way. In between them, one obstacle branch connected or having 200 ohm resistance and 10 volt energy source connected like this. D1 negative terminal is connected with 10 volt. 10 volt, okay. D2 and D2 terminal is connected with 8 volt. This is the situation, and the question reads is, this is the gate problem. 2 marks. Okay, and this is the dash fill up. Okay, and option are not given over here. You have to deduct your answer and come with the solution. See, for the circuit shown in the figure, for this circuit, assume ideal diodes with 0 forward resistance. These 2 diodes are ideal diodes. Okay, the conditions are given. D1 and D2 are ideal diodes. Okay, and 0 forward voltage drop. So the voltage drop is also 0 given over here. Voltage drop 0. Okay, 0 volt means it's completely ideal diode. The question is the current through the diode D2 is. The question is they're asking the current, find out the current in D2. Find out the current in D2. I am assuming this direction. They are not given. And the question is the current through the D2. They're asking current. Please read it carefully. Current in D2 in milliampere. You have to come with the answer and you have to give the answer in the milliampere. Okay, so let's check it. So in the last class I told you the method. If you are getting diodes, the first step is assume them short circuited, right? Here we are having D1 and D2. We are going to assume these 2 diodes short circuited. Okay, I'm shorting. Short circuited. Short circuited means they are working in the forward bias. Once you short circuited the diode D1, this 10 volt of the battery will come over this node. Okay, let's take the current in the diode D1 is I1, in the diode D2 is I2. Okay, so in the second stage, apply the nodal analysis and find out the current in D1 and D2. If the current in D1 and D2 are following the forward bias current condition, so we'll say that D1 and D2 will be in forward bias. If there is any fault, we'll say they are in negative bias. Let's check it. So 10 volt I'm going to apply over here the nodal analysis. So 10 minus 10 divided by 200. What about this incoming current I1? Fine, plus this branch. This one is short. Okay, so 10 minus 8. 10 minus 8 divided by, okay, this condition can't be fulfilled. Why? Because when you will short D1 and D2 both, the condition of faulty voltage is coming over here. At this stage A, you are having then 2 voltages, 10 volt and 8 volt. So this is not possible to short them. Okay, so we'll correct ourselves. We found the, here some wrongness is there. The question is, or our assumption is wrong. What I'm saying is our assumption is wrong. So we have to correct ourselves. Okay, we have to go. Wait a minute. I can't say that these two diodes are in short circuited. Then how I'll proceed it? Okay. See, if here the voltage is 8 volt. 8 volt means 8 or greater. 8 or greater means, see, I'm telling you two scenarios. Please carefully go through that. Okay. The question is, or I'm saying here at this node, there may be two conditions. It may be D1 in forward bias, it may be D2 in forward bias. Let's take D1 only in forward bias. If D1 in forward bias, the voltage over here will be 10 volt. Is it okay to you? If by chance D1 is on and your voltage at this node is 10 volt, what it means? It means that your D2 will also on. Is it okay? So this is fault condition occurring because at the particular node we can't have two voltages. So D1 can't be on. It will be off. Let's check then D2 is on. When D2 is on, here let's take the voltage is 8 volt. Let's take it voltage 8 volt. Okay, it may be greater than this, but let's take 8 volt. If 8 volt will be there, this diode will be definitely off, because at the negative terminal of the diode D1, I have 10 volt. At the positive terminal of the diode, I have 8 volt. Definitely D1 will be off. Our assumption is correct over here. So forget about this now. Your circuit is, your D2 is short circuited. Now your question is, find the current in D2. Simply you can find out the current. I D2 is nothing but 10 minus 8 divided by 200. Is it okay? So this is 2 by 200. So this is 1 by 100. So this is nothing but, it's like 10 milliampere. And they're asking in the milliampere. So you need to answer it 10 only, not 0.001 or 0.01. Sometimes people will write 0.01 and they'll get minus 0.67 if the question marks is 2 marks. Okay, immediately. Please read it carefully. They're asking in milliampere, so you have to answer in milliampere. Okay, this is the common problem people are doing in the examination. So please carefully read the question and then answer. Okay, otherwise what will happen? You solve the circuit. Yes, you are getting the right answer. Absolutely 100% right answer you are getting. But while answering this question, in terms of question, what they are asking, you are replying it wrongly. And because of this, you are losing your marks. Okay. So this is the third numerical of the day. I'll take another one and then we'll switch to the clamper circuit. The question given is, this is again gate problem. Okay. And the question given are, here I applied the input V in. Okay. In this branch I have diode circuit, diode D1 connected in this way. At the positive terminal of the diode I have 3 volt like this. In parallel with this branch I have D2 diode, at the negative terminal 6 volt. Here I am taking output from the circuit and this is R, and the question is, in the circuit shown in the figure, if Vi is 4, V in is 4 volt given. This is your question, right? They have given V in equal to 4. Assuming the diodes to be ideal, both D1 and D2 ideal. D1 and D2 both are ideal diodes. And the third condition is, find out V0. You have to find out V0. Here is the V0. Okay. So friends, V0 you have to find out. So I told you earlier how to check the diode condition. Just the step first is make them short or assume them short. Okay. Assume them short. If they are short like this. If they both will be short, this condition will be like fault voltage. Okay. Fault voltage will occur because at the particular node 3 volt and 6 volt can't occur. So leave this 2 now. Okay. This condition is wrongly. Okay, our assumption is wrong over here. Let me draw it again. It's given like this and it's given like this. Okay. Now what you have to do is, in the second step, you can open both of them. Open it. If they are open, the voltage at VA is 4 volt or not. If they are open. If they are open, VIN will be here only 4 volt. Now if this branch is throughout the 4 volt branch, now connect this D1 first. What will happen, we'll check. Connect this D1. If you will connect the D1 at the negative terminal 4 volt, at the positive terminal 3 volt, D1 will not work in the circuit. In the circuit, D1 will not work. Why? Because it has not sufficient condition to be forward bias. So it will be off. Come to the D2. Throughout the wire, your volt is 4 volt. At the positive terminal, you applied 4 volt. At the negative terminal, you will apply 6 volt. The condition is again reverse bias for D2. So it will be off. So your circuit will be like throughout D1 and D2, both will be open. So you will get output follows input and the answer is 4 volt. Okay. So this is your answer. Now we'll switch to the clamper circuit. Okay. The clamper circuits are used to store the DC. Okay. We'll be having signal, your input signal, input waveform. You can add the DC into this, or by adding DC you can change the position, right? You can change the position of waveform anywhere by adding DC component. So clamper circuit are the circuit which add the DC component. So I can say this is the DC storer. Okay. So see, in the positive clamper, what is going on? The positive clamper circuit is shown in the figure, in this figure. And though we are talking about the DC restorer or charge storing, so we'll use the capacitor in the circuit, right? So here the capacitor is given. So the positive clamper circuit shown in the figure, which introduces positive DC voltage equal to the peak of input signal. See, what it means is, in the, see, this is the positive half cycle and negative half cycle is given over here for the input Vin. Let's take it Vin. In the positive half cycle, the diode will be in reverse bias. So in the reverse bias condition, there is nothing to talk about. Okay, because capacitor will not charge. The capacitor will get the circuit, so it will become charged, right? So when it will get the charge, when the circuit will be in negative bias, or sorry, when input will work in the negative half cycle, and the negative half cycle, the diode will be open circuit, sorry, short circuit. When the diode will be short circuit in the negative cycle, the capacitor will start to charge itself. Up to which value it will charge itself? Minus 10. Is it okay? Minus 10 is given over here. So it will charge it fully at minus 10 volt, and after minus 10 volt, see, before 10 up to 10 it's working continuously, but let's talk about after minus 10. This is the minus 10. The input reaches to minus 10. The capacitor will charge itself up to minus 10. Now your input is decreasing from minus 10, or from minus 10 is coming to minus 9, minus 8 and 0 and plus 1, plus 2 and like this. So in this stage, how the diode will work? The diode will work immediately, like see, after minus 10 volt, it's coming to the capacitor is charged to minus 10 volt. Now polarity of your battery is changed. It is coming to minus 9, minus 8, minus 7 and like this. So the voltage across this is positive or not? Tell me. See, the situation is your diode is charged like this. Your diode is charged 10 volt. Now this is your input, and input is minus 9 volt. Let's take it after minus 10, it's reducing to minus 9. In this case, here the diode is also given, like let's take it like this. What is this voltage? 10 minus 9 means 1 volt. Once you have the 1 volt over here, your diode will be in reverse bias. So after reaching to minus 10 value, the diode will be fully drained or fully charged up to minus 10. And when the input is reduced itself after minus 10, the diode will be off now from the circuit. The diode will be off. Is it okay? Why diode will be off? Because diode is coming to the reverse bias now immediately. So when diode will be off, so this entire circuitry, the output will be V0. And this is the Vin, right? So output is nothing but, this is Vin, suppose, Vin plus 10. Is it okay? So you are adding 10 DC into the input waveform. That's why I'm calling it DC waveform. And we are adding 10, so we are calling it positive clamper. If you will change the diode condition, it will be negative clamper. So I hope this is clear. So entire waveform you have to shift by plus 10. Is it okay? Now how to shift plus 10 volt? This is the circuit given. You have to make it plus 10. You have to add plus 10 at every point. Okay, at every point. How you will add this and how you will make it. This point is at minus, this point is at minus 10. You will add plus 10. It will become 0. This point come to 0. Now each and every point will move accordingly like this, like this. Is it okay? Is there any problem? This 10 will become 20 now. So you shifted this entire waveform. How? By adding some DC terms. You add 10 volt DC over here. So this is the clamper circuit. Okay? We can change or we can add the DC part into the waveform. Is it okay? So let the input signal swings from plus 10 to minus. I showed all about this to you already. Now come to this circuit. See, this is the circuit given over here. This circuit is a bit different from the earlier one. In this circuit, to claim the input signal by a voltage other than peak voltage. See, in the last question or in the last circuit, what we did the circuit, we claimed the circuit. This procedure is called the clamping. We claimed the circuit by max value. See, what was the max value of this? 10 volt. The capacitor was charged up to 10 volt. 10 volt is nothing but the peak volt of the input waveform. See, this is the peak value. So we were charged the capacitor up to the peak value of the input, but if we don't want to charge it up to the peak value, so what will happen? We have to add some DC over here. Okay. So to claim the input signal by a voltage other than peak value, a DC source is required. A DC source is required. You can see over here. This is the DC source. As shown in the figure, the DC source is reverse biasing the diode. In this case, the DC source reversed bias the diode. It will be conduct only when this terminal will be at lower potential than minus 5 volt. Okay, means it will be minus 6, minus 7, minus 8 like this. Then only diode will be forward bias. Else it will be reverse bias throughout. Now let's check the condition. What value will be stored by capacitor C. And let's take V in is nothing but plus minus 10 swing. Let's take V in like this. Okay. The input voltage swings from plus 10 to minus 10. In the negative half cycle, when the voltage exceeds 5 volt C. In the negative half cycle only. Why I'm choosing negative half cycle? Because I need to come with forward biasing of the circuit. I need to come with this forward bias, because once diode will be in forward bias, the circuit will be complete and the capacitor will start to store the charges or charging itself. In other words, I can say. Is it okay? So when the diode will be in forward bias, when this value will be greater than minus 5, means less than minus 5, means minus 6, minus 7, minus 8, minus 9 and minus 10. For this all values, the diode will be in forward bias. Is it okay? So what they are saying, in the negative half cycle, when the voltage exceeds 5 volt, means negative minus 6, minus 7, then conduct. The diode D will conduct, and during the input voltage variation from -5 to -10, now see, this is -5 to -10, the diode will be in conduction. So the capacitor charges to 5 volt. Now capacitor will start to charge or not? See at the at the max value -10, what will be the capacitor value? Suppose the voltage across capacitor is Vc. So you can apply KVL in this circuit. You will get -10 plus Vc plus 5 equal to 0. So Vc is 5 volt. So Vc will be charged at max 5 volt. Up to 5 volt, this capacitor will charge itself. So the capacitor charges to 5 volt with the polarity shown in the figure. In this figure, you can see the polarity. Okay. Let me erase some parts so it will be crystal clear to you. Let me erase it. Okay. This is the circuit. The capacitor now charge up to 5 volt. Why 5 volt? Because of this DC 5 volt, the remaining part of -10 is cancelled out. Alright. Now, come to the next. After that, D2 becomes reverse bias. After this, what will happen? The waveform will change to itself. After -10, it will change to itself. Once when it will change to itself, the diode will become in the reverse bias. After the D becomes reverse bias and open circuited, the complete AC signal is shifted upward by 5 volt. Is it okay? Let's see the condition. The condition is now, how check the diode is in reverse bias or not. Okay. When diode is forward bias, the condition was the capacitor charge itself up to 5 volt and this is going to drop itself. After -10, it will come with value -9. Okay. Here is the diode. We'll check the diode condition. This is the 5 volt over here. We are going to apply the, we are going to apply KVL over here. It's -9, it's +5, it's +5. So this is nothing but V plus minus. So plus V equal to 0. So 5, 5, 1, V equal to -1 volt. So if V is -1, any diode having -1 volt means here plus, here minus. So it will be in reverse bias. So definitely when the voltage waveform decrease itself from -10 in negative region, the capacitor will be fully charged at 5 volt and diode will be immediately reverse bias. Okay. Let me clear it. Okay. So the diode, when the diode will be reverse bias, this circuit will be open and now entire V input will be aided by 5 volt. So your V0 will be V in plus 5 volt. Means your entire input stage will be shifted by 5 volt. You added 5 volt DC into the input, or I can say in other words, you claimed input by 5 volt DC. Is it okay? Now if this is your input waveform, you have to add 5 volt at each and every value. So your circuit will be like this. Okay. This is the part. This is suppose -5. -5 will become over here, will come like this, and each and every part. See, this 10 will reach to the 15. This is the 0. 0 line will come over here at 5. At 5 it will shift it. Okay, this is the 0 value shifted over here. We are not changing waveform over here. Waveform is same as it is, but we are adding some DC part. So there is a difference between clippers and clampers. In the clippers, we can modify the waveform. Modify the waveform by cutting it. In the clamper also we are modifying the input waveform, but the shape of the waveform is not changed. Shape is same. Is it okay? So what we are going to do over here, we are adding DC part. adding some DC part. So in the clamper, this is the DC restorer. I think the concept is pretty clear to you. Okay, now we'll see some problems on clippers, then we'll end this today's class. Okay, I'll take one clamper question and then we'll come to the voltage doubler. Okay, let me take over here one fresh page. Okay, the problem is given as the clamper circuit. Here this is the capacitor C, connected with input directly V in, like this. Here I have diode D. The positive terminal of the diode is assigned with 9 volt forward current or forward voltage. Here the output is V0. We have to draw the output waveform. Okay, and the input waveform is given square wave -12 to +12, like this. This is your input. This is +12, -12. Okay. Now friends, I'm telling you the procedure how to solve the clamper circuit. Okay. So I'll tell you the procedure how to solve the clamper circuit. So the first point is find out capacitor voltage at its steady state. Okay, means you have to find out the full capacitor voltage, and in the second stage you have to replace diode by open circuit. Replace diode by open circuit, and in the third, draw the output. Okay, these 3 steps we'll do for this circuit. Okay, let me change the pen color. Okay, so see, when this will be in positive half, this is the positive half, this is the negative half. In the positive half, definitely this diode will be in reverse bias. It will be already off, so we can't get the steady state value in the reverse bias, because if you want to charge the capacitor, you need to be one closed path, then only current will flow and the charge will store in the capacitor. Okay, so you need to be, this is the must condition, that your diode should be in forward bias in the initial state. To take the steady state output capacitor voltage, you need to be forward bias the diode, because in the second stage you are doing it open circuit. Okay, when the diode will be open circuit, this entire input and this will be come with V0. Okay, so when it will be in forward bias, definitely it will be in reverse negative cycle. In the negative cycle here, automatically the voltage is less than 9 volt, and it will be complete throughout this negative half cycle. The diode will be completely in forward bias. Okay, so the max value of this is -12. So the steady state will be, steady state means at the final stage it will be charged with 12 volt, and the polarity is given like this. Why minus? Because the minus half is applied to the capacitor. Okay, this is the fully charged condition. Now what is the point? The point is, second, replace the diode by open circuit. In the next, we don't have this diode now. Okay, but before that, let me clear it. I made some mistakes over here. When diode will be in forward bias, the capacitor fully steady state will be V in max is -12. So -12, let's take it minus plus. So this is plus VC, and here -9 also given. So VC will be 12 plus 9, 21. 21, and the polarity I already assumed in this way. Okay, so this is 21 volt. Now this is the steady state voltage across the capacitor. I can say the capacitor is fully charged now. Now once the capacitor is fully charged, you have to replace the diode by open circuit. I'm going to replace the diode by open circuit once the capacitor is fully charged. Let me assign the value. This is -21 volt. The capacitor is fully charged. Next step, the diode is opened or reverse bias. In the reverse bias condition, now please apply the KVL in the circuit. Start with the V in minus plus 21, and this is plus minus V naught. So minus V naught equal to 0. So V naught is nothing but V in plus 21. So there will be plus 21 swing into the input. So if this is the input, output will be, what will be the output? I'm going to draw it. Okay. Let me clear some parts so it will be easy to draw. Okay. Here I'll draw the output waveform. Okay. My output is coming V in plus 21. This is the V in. This 12 will go to the 12 plus 21. Okay. This is the 12 point, right? So this is 12 plus 21 will be 33. This point will go to the 33. This is 33. What about this? This is the 0, right? This is the 0. 0 will be added with 21. So the circuit will be like this is the 21. So 0 will reach to the 21. What about this minus 12? Minus 12 will reach to the minus 12 plus 21. So it will be 8 plus 1, 9. It will be at 9. It will be at 9. Okay. This is your input now. Output, sorry. So you shifted your output waveform like this. Your waveform is similar to the original one, but it's shifted, or you have added some DC part in it. Is it okay, friends? So this is all about the clamper circuit. In the clamper, you are adding the DC part, and in the clipper, you are cutting the waveform. Okay. So friends, this is all about this third video lecture. We'll meet in the fourth one, and we'll see some theory part, and again we'll solve some problems. Okay. We'll meet in the next. Till then, take care and bye.